Hi students, welcome to Suneel Engineering Academy. I am Sunil Kumar Bandaru, press educator in an academy. Students, from today onwards, we are going to start network analysis, which is very useful for both electrical and also electronics engineering students for your various JE and AE examinations. In this course, I will discuss each and every topic which is useful for your examination. So don't skip any video. Okay, let us start the session. A small introduction about myself. I have 4 years of teaching experience in online platform and I have cleared many written examinations like GATE, SAIL, Management Training, Prasar Bharati, SSC JE and recent Rrb Je, and presently working as an engineer in government sector and so many selections through this YouTube channel Suneel Engineering Academy. So please subscribe this channel. Okay, you will get a lot of benefits. And let us start the session. In this network analysis or circuit analysis, first of all, I want to start with the basics of network analysis. First of all, I want to discuss about charge, very fundamental quantity, charge. We know very well charge is denoted with the letter Q. Okay, charge. First of all, what is meant by charge? Charge is nothing but which experiences electrical forces. Which experiences electrical forces is nothing but we can say charge. This charge may be negative or positive or zero charge. Okay, so that means we can say that charge is nothing but which experiences electrical forces. Is nothing but we can say charge. This charge may be positive charge or negative charge. Okay, so positive charge is just denoted by plus Q and it is denoted by minus Q. We know very well proton having positive charge. Okay, and that value is nothing but plus 1.602 into 10 power minus 19 coulombs. That means you can say charge units are coulombs. Charge units, very important, coulombs. Okay, why we have given the unit as coulombs? Because to recognize the scientist Coulomb. Coulomb has given two important laws based on the charge between the two quantities. Okay, so we will also discuss those Coulomb's laws also in this class. And coming to the same electron having negative charge, the magnitude is same, 1.602 into 10 power minus 19 coulombs. These values are also very important for our non-technical examinations. Okay, and after that we know very well neutron has no charge. Okay, and here these charges are maybe positive or negative. That is, a proton is a positive, electron is said to be negative, neutron is said to be no charge. Here the Coulomb's is a scientist given two important laws on this charge. Coming to Coulomb's first law. Coulomb's first law will give the nature of force exist between the two charges. Which type of force? Nature means which type of force, that is either attractive force or repulsive force. Okay, so the first law will give the nature of the force exist between the two charges, and the second law will give the magnitude of the force. Same, not only this Coulomb's law, if you can consider Faraday's law, if you can consider Newton's law, first law maybe give the definition or nature. Okay, second law will give the magnitude. For example, in the Faraday's first law, it will give how the EMF will be induced. Second law will give the magnitude of the EMF. Same like Newton's first law will give the definition of the force, and second law will give the magnitude of the force, F is equal to ma. Like that here also Coulomb's first law will give the nature of force exists between the two static charges. Static charges. That means has given like nature of force, which type of force, that is attractive or repulsive. For example, if the charges are same, that means like charges, both are plus or both are minus. Like charges are repel to each other, unlike charges are attract each other. That is given by this first law. Like charges repel, unlike charges attract. Charges attract. Okay, for example, if we have positive charge, here also positive charge, then there is a repulsive force will be exist between the two static charges if those are separated with the distance d. For example, if one charge is positive, one charge is negative, that means unlike charges, if we are displaced with a distance d, there is a force of attraction will be experienced between the two static charges. That is given by the first law. Okay, I think all of you got understand about the first law. First law will give the nature of force exists between the two static charges, like poles as like charges repel, unlike charges attract. And coming to the second one, Coulomb's second law. Coulomb's second law. Coulomb's second law will give the magnitude of force between the two static charges. Magnitude of force between two static charges. Two static charges. Okay. So what is that magnitude? For example, if we displace the two charges as plus q and minus q, or you can take both are plus also, nothing problem. Okay, nothing problem. For example, let us take both are plus, that is not a problem. Let us take it is a charge 1 and it is a charge 2. Okay, so if both are same charges, means there is a force of repulsion will be exist. If you displace these two charges with a distance d, d is the separation. Okay, d is the separation, q1 q2 are two charges. If we displace the two charges with some space or some separation, there is a force of repulsion or force of attraction will be exist. Here like charges, so that's why force of repulsion may be exist. So then what is that magnitude? That magnitude of force is directly proportional to product of those two charges. Very, very important point. Product of those two charges by the distance square. The distance square. That means from this formula we can understand a very important point. The first very important point is nothing but force is directly proportional to product of two charges. That means as the charges are very high, force exists also very high. All of you getting my point? And the second one, if we displace them with a longer distance, that means as the distance is higher, the force exist will be lower. Okay, that means if the distance is low, high amount of force is exist. Okay, that is inversely proportional. For example, if the two charges are placed very near, then a lot of force is exist. If the two charges are displaced very far, then the force is very less. Okay, the force is very less. For example, if we can say if the lovers are very near to each other, they have a lot of attracting force. Okay, if they are far, the force is less. Same like that here also. Okay, and here force proportional to q1 q2 by d square. We know very basic thing. If you remove the proportionality constant, we have to replace with one constant. So I am replacing with one constant, that is k into q1 q2 by d square. Here what is this k? K is a constant. That constant is nothing but 1 by 4 pi epsilon. 1 by 4 pi epsilon. That means the displacement, that means here the force is also depend upon this epsilon. That means permittivity. We know very well epsilon is the permittivity. Okay, so that means here we can say that the force is depends on the permittivity also. the permittivity also. We know very well permittivity is epsilon is equal to epsilon naught into epsilon r. Epsilon naught into epsilon r. We know very well epsilon naught value is nothing but 8.85 into 10 power minus 12 farad per meter, minus 12 farad per meter, and epsilon r for air is equal to 1. Relative permittivity is equal to 1. And these units are also very important, friends. Permittivity farad per meter, relative permittivity no units. Okay, and if you replace that one in this equation, force is equal to K. In the place of K, I am substituting 4 pi epsilon naught epsilon r q1 q2 by d square. Okay, so I am substituting the values epsilon naught and epsilon r value, and if we calculate in detail, okay, if you calculate in detail, that is 4 pi into 8.85 into 10 power minus 12 into 1 q1 q2 by d square. Okay, if you calculate, you will get a final value 9 into 10 power 9 q1 q2 by d square. Very important formula. Very important formula for your JE examinations. We know very well force units are newtons. Okay, so all of you try to remember directly. Force is equal to 9 into 10 power 9 q1 q2 by d square. Okay, q1 q2 by d square. And we know very well charge units are coulombs and distance units are meters, force units are newtons. Okay, and here I want to give a small problem, then you will get understand of this formula very easily. For example, if they have given the problem is like that, find the force between two charges of 8 microcoulombs and 6 microcoulombs when they are separated at 10 centimeter apart in air. So if they are asking apart in air, directly you can take that ER is equal to 1. You can take the formula, direct formula. How to solve this one? All of you try to solve. After that, check with my answer. We know the formula for force is nothing but 9 into 10 power 9, the product of two charges q1 q2 by d square. Charge is in coulombs, distance is in meters. Okay, so 9 into 10 power 9 into that charge 8 into 10 power minus 6 coulombs q2 6 into 10 power minus 6 coulombs by d square is in meter. So they have given centimeter means 0.1 meter na 0.1 meter. Okay, so 0.1 meter means we have to take 0.1 whole square. Okay, so if you solve this one, you will get the force nearly 43.2 newtons. Okay, so we have to be careful while substituting the values, because we have to substitute proper units, then only we will get the correct answer. Okay, so like this you can find out the force between the two static charges. Okay, it will be useful for all your JE examinations, and in the AE exams also we are getting this type of very simple problems. Okay, so once again friends, charge is nothing but which experiences electrical forces. Okay, these charges experiences the electrical forces, and based on this upon this charge, Coulombs has given two laws. First law will give the nature, second law will give the magnitude, and that magnitude value is nothing but 9 into 10 power 9 q1 q2 by d square. Okay, and we have solved a problem. Current. Okay, we know very well we are denoting this current as letter I. I think all of you know the definition of the current. For example, if the water is moving, we can say that is a water current. Okay, if the water is moving, we can say that is a water current. Like that, if the electrons are moving, we can say electric current. Nothing in this. Okay, so if we have moving, that means moving particles, then we can say that is a current. So that means, for example, if the charge is flowing, we can say that rate of flow of charge. That rate of flow of charge is nothing but we can say current. Okay, so that means if the charge is flowing, okay, but with how much rate it is moving slowly or moving fastly is given by the current. I think all of you got understand now. What is meant by current? For example, if the charge is moving from one place to another place or one point to another point or one side to another side, okay, with how much rate the charge is moving. If the charge is moving very fastly, you can say either current. Okay, so same like that. So we can define that current is rate of flow of charge. Rate of flow of charge. Okay, that means charge is flowing with the how much rate. So we can give that I is equal to dq by dt, rate of flow of charge, or we can denote this I is equal to rate of flow of charge q by t. Okay, rate of flow of charge q by t. So we know very well charge units are coulombs, time units are seconds, then current units are amperes. Okay, to recognize the scientist ampere, we are giving the current units are ampere. From this, we can say that 1 ampere is equal to 1 coulomb per 1 second. Very important relation. Very important, friends. Okay, 1 ampere is equal to 1 coulomb per second. Or from this relation, we can also say that 1 coulomb is equal to 1 ampere into second. 1 ampere into second. Okay, I think we know very well batteries are denoted with ampere hour. Why ampere hour? Batteries are nothing but their capacity. We can say that how much of charge in it. How much of charge in it. Okay, that is the charge now. So that is the charge Q. Ampere, that is nothing but we can say current, and time T. So Q is equal to I into T now. So that's why we can say we are denoting the capacity of the battery is in ampere hour. Okay, current ampere, time hour. So that is capacity of the battery, you can say that ampere hour. Okay, and here very important thing is that if you want to get the current in amperes, you have to substitute the charge is in coulombs and time in seconds only. Okay, time in seconds only. And we can also define the current as flow of electrons. Flow of electrons or movement of electrons. Okay, so whenever we have the free electrons in the element, in the any metal, okay, in the any substance, then the electrons may move from one side to another side. Then there is a current will be flowing in that. Okay, I think all of you got it. For example, if the less current is flowing means the charge is moving slowly. High current means charge is moving fastly. That is only. Okay, that is a very basic idea. Very basic idea. For example, we can say that if the for example, water in the horizontal, it may be flow with very little bit of speed, and in case of from high to low, if the from higher to lower height, it will be moving very high, very high speed. Okay, very high speed. Why? Because that will be depends upon the difference, pressure difference, height difference. Like that here also, if we have the more potential difference, more current will be flow. More potential difference, more current will be flow, like that. Okay, so here a very important simple problem is there. Okay, this problem is repeated so many times, so that's why I'm giving this one. Okay, all of you try to note down. Here the simple problem is that a current of 0.5 amps is drawn by a filament of electric bulb for 10 minutes, then charge Q is dash. Then charge Q is dash. Okay, then charge Q is dash. So we know very well current is nothing but rate of flow of charge. Here they are asking charge na, so charge is equal to I into T. So what is the current? They have given 0.5 amps, and what is the time? Time they have given in minutes, but in the previous slide I have given that 1 ampere is equal to 1 coulomb per 1 second. So if you want in coulomb, we have to substitute in ampere second na. So here also we have to substitute in seconds. So 10 minutes into 60 seconds. So that is you are getting 300 coulombs. Most of the students will do mistake. They will just take 10. Then 10 into 0.55. 5 is maybe the first option, and we are getting the wrong thing, wrong answer. Okay. So we are missing we are getting minus 0.25 or minus 0.33. Okay, so we don't want to do like that. Be careful while substituting the values. Okay, while substituting the values. I think all of you got it. Now we are going to discuss the potential or potential difference or voltage. Potential or voltage. Okay, here this potential or voltage is nothing but it is the work done on unit positive charge to take it from one point to another point. For example, we can say if any charge is on the point A, okay, charge is on the point A. If it want to move from A to B point, we require some energy now. We require some energy or not? If you provide some energy, the charge may be moving from one point to another point. For example, here we can say if you want to send the water from down floor to first floor or second floor or third floor, like that. If you want to send the water, then what we are doing? We are providing a motor. Okay, we are switching on the motor. Then what is happening? This motor creates the pressure difference. Due to that, the water is flowing from this side to this side. Here it may be high pressure, it may be low pressure. Okay, so then water is moving. So here also, if you want to send the charge from one point to another point, we require some energy. Okay, we have to do some work. Am I correct? Here motor is doing the work. Here we have to do the work. That work done by the unit positive charge. Is nothing but potential or voltage. That means if you give the potential, if you give the voltage, then charge is moving. And the charge is moving, you can say that is the current. If the charge is moving, you can say that is current. That means you can understand that if you apply voltage, if you give some potential, then charge may be moving, then current may be moving. All of you getting my point? Okay. So here you can say that the potential or voltage is nothing but denoted by the letter V. It is nothing but V is work done on unit positive charge. On unit positive charge. Okay, so we can also define this one in unofficially. You can define this one. Voltage is nothing but it is the energy required to move the charge or to move the current, or to flow the current. Okay, to move the electron, to move the charge, to move the to flow the current. Energy required to flow the current. Okay, so that means if you apply the voltage, then current will be flowing. For example, we can understand this one. If we have the water in the tank, and here we have the tap like this. Okay, here the water level is like this. That means this much of potential we have here. And if you take the another tank which is also having same water level, then water may flow to A to B or B to A. Here there is no flow of water takes place. Am I correct? Water may not flows from A to B or B to A. Why? Because here same water level, here same water level. Okay, water levels are same, means same pressure in the A and in the B. So there is no water will flow from A to B or B to A. Okay, so that means you can say that whenever there is no pressure difference, there is no water flow. In the same manner, if we understand this one, if there is no potential difference, then there is no current flow. Okay, for example, here we have zero potential, here also zero potential, and zero potential. There is no flow of the current. So one important condition, if the current want to flow, there must be a voltage difference, there must be a potential difference. Okay, for example, sir, if you said that if there is a same potential at both, there is no flow of current. But if you are giving the supply, that is for example single phase supply 230 volts, then how the current will flow? Here in the single phase supply, the phase is given to 230 volts and neutral is having 0 volts. Then what is happening? If here you are connecting a circuit, any bulb or any device, then here higher voltage, here lower voltage. Then what is happening? Current always takes from high potential to low potential. So current will be flow from 230 to 0 volt. But we are giving the path, that path is connected to this load. So that's why current also flowing through the load. Okay, so that's why the load is getting the current and that is working. Okay, for example, we can also understand that if we have the perfectly horizontal tube having 1 kilometer, okay, it is a perfectly horizontal. Here same pressure, here same pressure. Then water may not flow from one side to another side. For example, the same this 1 kilometer of the pipe is vertically inclined like this. Then without any external force, it is moving or not? Why? Because here higher the pressure, here the lower the pressure. That means here also whenever there is a high potential and low potential at each ends, okay, then automatically current will be flowing. So we can understand this one. To flow the current, we must have potential difference. If you don't have potential difference, how to get? By providing the supply. Or by connecting the battery. For example, if you connect the battery, 10 volt battery, if you connect, positive is 10 volt, negative is 0 volt. Okay, then what is happening? Here 10 volts, here 0 volts. There is a potential difference. Then current will be flowing. Okay, then current will be flowing like that. Okay, so if the current want to flow, the two important condition, there must be a potential difference. The second one, the circuit must be closed loop. Okay, so we can say to flow the current, the first point, there must be a potential difference. There must be a potential or voltage difference. Okay, this can be created by battery, or electrical supply. any single phase, three phase or whatever. Second one, circuit must be closed. Circuit must be closed. Then the current will be flow. Okay, all of you getting my point? Yes. Now here this work done, this voltage is equal to work done by unit positive charge, work done by charge. Okay, and it is a very important relation. V is equal to work done by unit positive charge. Work done units are joules. Charge units are nothing but coulombs. Voltage units are nothing but volts. Okay, from this 1 volt is equal to 1 joule per 1 coulomb. Very, 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 very important relation. Very, very important relation. In some of the examinations, they will give that some voltage value and some charge value, and they are asking the work done. Then we can easily calculate work done is equal to voltage into charge. Voltage into charge. Okay, from this one also we can get a answer. Okay, I think all of you understand what is the voltage difference or potential difference and what is the voltage and all those. Okay, so here if you consider difference of this one, VA minus VB, so that is nothing but VAB. Okay, generally VAB is nothing but you can say VB. Ohm's law will gives the relation between voltage and current. Gives the relation between voltage and current. Okay, let us understand. If you can consider a resistor, if you apply the voltage or if you maintain a potential difference between the resistor, 2 points or across this resistor, then current will be flowing. Current will be flowing. If you increase the voltage, then current flowing also increases. Okay, that means the current flowing is depends on the voltage applied or depends upon the potential difference maintained across the resistor. Okay, so we can say that Ohm's law is nothing but at a constant temperature, the current flowing through conductor, the current flowing through the conductor is directly proportional to potential difference maintained across that, are proportional to applied voltage. Okay, so the current flowing is directly proportional to the voltage applied. So we can represent this one as mathematically V proportional to I. Okay, that means current will be depends on the voltage difference or applied voltage. Okay, so if you say like this, then V by I must be a constant. V by I must be a constant. That constant is nothing but resistor. All of you be careful, listen. This resistance is a constant, then only the Ohm's law is applicable. When the resistance is constant, whenever the temperature is constant, then only resistance is a constant. All of you getting my point? Whenever the temperature is constant, then only resistance is constant. Otherwise, for example, in case of conductors, as the temperature increases, resistance also increases. In case of semiconductors, as the temperature increases, resistance is decreases. Okay, so that means you can understand that as temperature varies, resistance is varies. If the resistance is varies, then Ohm's law is not applicable. Ohm's law is not applicable. So we can say this Ohm's law is applicable to the conductors which are not depend upon the temperature, which resistance values may not vary with very high values with respect to the temperature. Okay, so V proportional to I, or V is by I is equal to R. So we can say V is equal to I into R. So this is nothing but you can say Ohm's law, where R is constant or temperature is a constant. Okay, I think all of you got it. So V is equal to IR is the Ohm's law. Sometimes we are also getting the questions on this Ohm's law, that is nothing but the curve represents the Ohm's law is dash. So as V proportional to I, that means if you increase the voltage, then current also increases. Okay, so VI, as you increase the voltage, current also increases. Okay, so coming to the slope is nothing but y-axis by x-axis. R is equal to y-axis V, x-axis I. V by I, it is a constant. It is a constant. So resistance is a constant. That means we are getting a linear curve. Linear curve you are getting. Very important. The curve represented by Ohm's law is nothing but linear curve. Linear curve. Okay, now we are going to discuss about the resistance. Here we have the resistance is a constant. Now we have to discuss about the resistance. Before going to discuss the resistance, what are the limitations in case of Ohm's law? Coming to the limitations of the Ohm's law, these are very important. Limitations. These limitations are very important. First one, okay, temperature must be constant. If here temperature must be constant, so Ohm's law not applicable to conductors, whose resistance varies considerably with the temperature. Okay, and the second one, not applicable to, say, not applicable to first one, temperature must be constant. So Ohm's law not applicable to conductors whose resistance varies considerably with the temperature. With the temperature. It is not applicable to electrolytes. It is not applicable to electrolytes, for example, like H2SO4 in case of electrodes. It is not applicable. For semiconductors, and in case of vacuum tubes, that means you can say which are non-linear characteristics. For non-linear characteristic devices, it is not applicable. Okay, so and also in case of insulators, okay, that means it is applicable to only conductors as soon as the temperature is constant. All of you getting my point? Ohm's law is applicable to conductors as soon as the temperature is constant. If the temperature varies, Ohm's law is not applicable. Okay, but it is very famous. Okay, all of you getting? So these are the limitations, and it is the Ohm's law. V is equal to I into R. From this one, you can say I is equal to V by R. or R is equal to V by I. We are using this Ohm's law in so many cases. Okay, without Ohm's law, we can say there is no electrical engineering. Okay, that much of